The title of his talk today is Securing Web Apps with Modern Platform Features. And please give Lukas a second warm welcome of applause. Thank you. Round of applause. Thanks.
Thank you. Thank you very much.
Enjoy
Thank you. Yes. So, hello. Welcome, everyone. I'm really glad to be here. So many familiar faces. Today, we'll talk about securing web apps with modern platform security features. Sounds a bit cryptic, but actually it's just about how can we leverage features in the browser to basically protect web applications from entire classes of vulnerabilities. I work in Switzerland, but maybe you have already noticed my English is not as charming as Adam's. So I'm not a native speaker. I'm also not Swiss. I actually studied in St. Pölten. And believe it or not, back in the days, Johann Haag was actually a teacher there. And already back then, he was very passionate about security and networking. And he kind of sparked the interest in security in me there. So a couple years fast forward, I'm still passionate. I'm actually very passionate about security, and especially web security. And I was lucky to basically end up in a team at Google that focuses on actually trying to identify entire classes of vulnerabilities, analyze them, and try to find mechanisms in the web platform to fix them. Because we thought, like, okay, how can we fix all these cross-subscripting vulnerabilities at Google? And then there's like a couple of techniques. And it's like, maybe it's better to actually fix them for all in the web platform, right? Because the browser actually has a lot of context, and it's a good place to start it. So today's talk will basically be split into two topics. First, I want to get everyone on the same page, explain a couple of common web security flaws. This will be like a very short part. And the second part is actually the main part, where I will introduce like 4 web platform features that can be used to mitigate or harden against a couple of common vulnerability classes we see there. So, we basically are very data-driven, and we are very lucky because at Google we have a VRP program, which basically means that anyone can send bugs to Google, and Google pays for them. And of course, these bugs ideally get fixed. But for my team, what is even more important about that, we basically see trends in bugs, right? We basically see what kind of vulnerabilities are reported and what are the root causes for these. And with this data, we can basically try to come up with rough approximation of like what are the classes of vulnerabilities. And I mean, that will probably not be like mind-blowing to you, but at least for Google, the more than 50% are web application bugs. The non-web bugs are basically mobile vulnerabilities, business logic, server, misconfiguration, etc. But in this talk, I will focus on the web part. The biggest group is actually cross-site scripting, which is sad because I think cross-site scripting is around for too many years. And yeah, the others are also very well known. It's like cross-site request forgery, clickjacking, and a couple of others. And there's actually a couple of new ones like Spectre-based attacks, etc. So just a super quick recap. I guess many people in the audience know what cross-site scripting is. It's basically taking untrusted input, except like for example from a query parameter, and now even have a laser. Basically taking that untrusted user input and putting it back into the DOM. And by that, you basically an attacker can execute scripts in the context of a user. Usually, you'll see like an alert box, which is like kind of harmless. But actually, we treat these bugs extremely serious because if you have a script execution in the context of a user, you have access to all the data. You can basically do all the actions that a user could do on a web page. And if you have a blog, that might not be a big problem, but if it's like an application like Gmail or Drive or whatever, right, that is like probably one of the worst things that can happen there, which brings us back to threat modeling, I guess. So the other category we'll talk about today is insufficient isolation. I don't know if this type of categorization has occurred to you before, but basically this category is like old bugs that are basically caused by two origins not being isolated properly from each other. One common example is cross-site request forgery. What happens is that, victim visits evil.com, there's a form, the form is pre-filled with a recipient and an amount, and then on evil.com there's a piece of JavaScript that submits this data to your bank. And since, if the user is logged in, the browser attaches cookies to all these requests. The bank will get the request, see there's like a valid transaction with a cookie, the user is logged in, and will perform the action. That's pretty bad. And the bank basically on the server side has no way to tell apart was this initiated by the user or not. So we'll come back to that in a bit. As I said, there's also very interesting new classes of vulnerabilities here. So now in web security, we also have to deal about vulnerabilities in the microarchitecture of the processors, which is interesting, right? Like Spectre and Meltdown. And the web platform actually offers a lot of advanced APIs, which are really great, especially to help developers to shoot themselves into the foot. Basically this leads to attacks like cross-site search. This is also it's not that new, but a somewhat new category. So this was data from the Google VRP program, but actually, if you look at data from HackerOne, the distributions are similar, right? And that's actually not a surprise, and you can also look at the OWASP top 10, etc., right? So what can we do about these vulnerabilities in the web platform, in the browser, right? Our team basically is in this like very sweet spot where we basically, on the one hand, can work with all the product teams like Gmail, Drive, etc. And on the other hand, we can work with Chrome and other browser vendors and W3C to basically take a new web platform security feature, roll it out internally, like on 100 products, just for internal traffic, and test this feature. And we basically can take what we learned from this back to the spec writers, to the browser vendors, and tell them, this is like a good idea, but here and there it is problematic because like the way web applications are built, this will not be deployable. So this is very interesting. And once we ended up with a working feature, we actually tried to roll it out in like all the products. So the defenses are split into two groups, same as the ones I actually just presented. And I will present two browser features in each category. I think the first one might be known by some people. I'm actually dusting off content security policy a bit. Who of you has heard about content security policy in the past? Oh, cool. That's great. So content security policy is around for a while, and it's completely useless the way it was created, at least to protect against cross-site scripting. So in theory, CSP, if you use it for XSS defense, allows you to control scripts and plugins that are executed on your page. It's a defense in depth mechanism. That's also something that people sometimes get wrong. And because of that, it should always be like a second line of defense and should not be your primary mechanism to protect against XSS. So even if you have a very good CSP, you still need to have proper escaping and fix the actual bugs. So CSP, right, is this thing. Who of you has seen policies like that? Yeah, that's the header. That's the response header. So this is how most people use CSP. They basically put a list of hosts, and the browser will basically only allow executing scripts that are loaded from any of these hosts. It's a terrible idea. It's easy to bypass. We actually wrote a CCS paper about that. In most cases, it's almost impossible to maintain. You have to create like a list for every endpoint, right? And it changes, so you'll probably end up with breakages. So what we did is we talked with Chrome folks, and we said, like, we need to do something here, right? Because the basic idea is good. We want to restrict the script execution. So that is bad. What we do instead is we use CSP with nonces. Funny enough, like a nonce-based CSP is available since CSP2, which is actually around for some years as well already. The primary idea is the CSP response header has a nonce which is random and generated for every single response, right? And only scripts in the markup of the page will be allowed to execute that have the same nonce attribute set. So if you have a XSS vulnerability on your page and an attacker manages to inject some scripts there, he will be able to inject a script tag, but he will not be able to guess the nonce because the nonce changes on every response. Of course, the nonce should be random and not guessable, right? This is great, but in practice did not really work because you basically had to nonce every single script tag on the page, even the ones that were like dynamically created. So if you load like a Twitter widget, that widget creates new scripts, and Twitter maybe cares or maybe does not care about CSP, so this script does not have a nonce in the end, right? So what we said is we need something like strict dynamic. We actually proposed to add this in CSP3. And the basic idea is if you have a trusted script that has the nonce in the initial page markup, that script can already execute code, right? So why not just allow it to also load other scripts, right? So it basically means that trusted scripts can propagate their trust down the road to other dynamically loaded scripts. On the one hand, this is great because it basically makes CSP super easy to deploy. You only have to use this string as a policy with a varying nonce. On the other hand, you sacrifice a bit of security here, right? It's a trade-off. So this policy is very strong to protect against XSS attacks that are based on JavaScript URIs, inline event handlers, also the classical server-side, stored and reflected XSS, but it's kind of weaker for DOM-based XSS, right? So we basically rolled out this policy at Google on over 70% of the outgoing traffic, like all the big applications like Gmail, etc. And from the VRP program, we basically were able to verify how many of the reported XSS on pages that had CSP were actually blocked. And it was actually pretty good. It had like at least 80% of them were completely blocked without bypasses because the XSS was either like using JavaScript URIs or these kind of things. So that's a very good start for the classical XSS. And it's very good to basically reduce the attack surface of your website, right? Because if you basically disallow certain types of dangerous patterns like eval, inline scripts, JavaScript URIs, these tools basically disappear from the palette of what the attacker can choose from to create an exploit, right? And if the vulnerability is only in that part of the code, it will not be exploitable anymore. So I could talk about this topic, I think, for like at least 6 hours, right? So, but it's probably better to have other talks later. So maybe you just read it up if you're interested in that topic. And I also coded up a quick tool to basically check CSPs, and they are usually all bypassable if you paste a whitelist-based CSP. So the tool just tells you like JSON-B endpoints on all the common domains that are usually whitelisted. And because of that, usually these whitelist-based CSPs can be bypassed. Yes, so what about DOM-based XSS then, right? So we have the classical XSS with CSP3. We also want to protect against DOM-based XSS. So there's a very new feature coming up, which is trusted types. Has anyone heard about trusted types yet? Amazing, 3 people, amazing. So this is basically brand new. It's supposed to launch in Chrome 80, which is probably January. And the concept is really nice. First, a super quick recap of what DOM-based XSS is. DOM XSS is basically a variant of XSS where, user-controlled strings somehow end up being treated as code. I think that's like a common pattern in security. And in the case of DOM-based XSS, this happens because, the DOM APIs are sometimes very dangerous. For example, inner HTML, window.open, and 60 other APIs like that basically allow script execution in some form if you pass a user-controllable string to them, right? The basic example is, you have a URL fragment which is completely controllable by an attacker, and you take this URL fragment and paste it to inner HTML. So this will basically lead to a DOM-based XSS attack. Yeah, that's just some of the attack vectors, right? The really bad thing is if you're a security auditor, right, and you basically review a product before launch, and there's like, what, 100, 300, or like 900 kilobytes of JavaScript code. Good luck grabbing for all these keywords, right? And trying to find from where all the user input is piped through the entire program, and eventually maybe or maybe not ends up in any of these things, right? It's a nightmare for a reviewer. So the basic idea is very simple. If you enable trusted types, the browser basically stops accepting strings for these things. So for example, if you want to use inner HTML, instead of a string, you have to pass a trusted HTML object. And the important thing is, to create a trusted HTML object, you need to define a policy function in JavaScript. This policy function basically has all the security critical code in it, and that needs to be reviewed by a security reviewer. But the nice thing is, it basically moves like security and sanitization and escaping, etc., into a single place in the code, right? So this makes it very tractable, and it's delivered via CSP as well. Uses CSP as a delivery mechanism, and you just enable it with trusted types, and then the policy names you use to create. I skipped a bit of technical content here because of timing reasons, but the TLDR is, if that's enabled, string assignment to inner HTML will be blocked by the browser, and only trusted HTML objects will be allowed to be assigned and executed. So that's the Injection Defenses 2019 edition. Well, actually it's a bit 2020 because it's supposed to launch in January, I guess. But the TLDR is, you basically try to mitigate the server-side XSS, the classical XSS, and the JavaScript UI-based XSS with CSP3, with a nonce-based CSP. And then the client-side DOM-based XSS with trusted types. And the nice thing is, you can actually enable this in a single header. I'm not saying this is perfect, but I also think that this will significantly reduce the amount of exploitable vulnerabilities in platforms. And especially trusted types is not a mitigation, it's actually a hardening feature, because you actually have to rewrite your code, and by that you actually remove a lot of attack vectors if you make it compatible to trusted types. So isolation mechanisms, these things are basically brand new, and I'm actually really excited about them. And the question is, why do we need isolation on the web? Basically, there's two types of attacks. There's attacks on resources, basically attacks like cross-site request forgery, XSSI, clickjacking, web timing attacks, Spectre. And the common theme is for all of these attacks that it's usually evil.example requesting something from victim.example. And you know, if a browser makes a request, it usually attaches cookies to the request, right? So this is the first category. The second category is like attacks on Windows. So why would you care about Windows? It's actually interesting, but you know, if you open a window from evil.example, like window.open victim.example, evil.example still has a reference to this window, and that basically lets you, enumerate iframes, navigate the child window. It leads to some types of access search attacks, and in some browsers that also causes these two windows, these two origins, to end up in the same browsing context group in the same process, which can lead to Spectre attacks. So, before I start with the first new mechanism, I wanted to do like a super quick review of origin and site. I think most people are familiar with the same origin concept. If you have www.google.com and www.google.com/bar, and they basically have same scheme, same host, same port, these are considered same origin. But for example, if you have just the same scheme and the same registrable domain, which usually boils down to subdomains, but not just that, you have a same site concept. So for example, mail.google.com and photos.google.com are same site to each other. And basically, everything else is cross-site. So the first mechanism in that category, especially to basically protect resources, is fetch metadata request headers. Anyone heard about this? Amazing. One person, amazing, yes. So I really love this idea, and I'm really curious what you think about it, because it's actually simple, but makes a lot of sense in my opinion. The TLDR is, it helps the server to make a decision if a request comes from a cross-origin context or not. And by that, you can basically prevent an entire class of vulnerabilities. So first, let me explain what this is. Fetch metadata is actually just request headers. Yes, request headers. It is the browser that sends an additional amount of information to the server to help the server to make a decision if the server wants to process this request or not. And it's basically 3 request headers. The first one is SECFetch site, which basically indicates if the site from which the request came is same origin, same site, or cross-site to the server that the request is going to. So think about it. You can actually now know on the server if evil.com just loaded this form and clicked via JavaScript on the submit button to submit it to the bank, right? And potentially prevent cross-site scripting on the server. The second one is SECFetch mode. It's basically the request mode. TLDR is basically, it's just like, is it coarse, is it not coarse, or is it a navigation? We'll see in a bit why this is important. And the last one is SECFetch user. That basically indicates if a navigation was actually initiated because of a user gesture, like a click, button press, keyboard press, etc. So here's an example. You have site.example making a fetch request to site.example. So this is same origin. So the browser will basically tell the server, this is a same origin request. Since it's like a fetch request, it's a SECFetch mode course. Let's go back to evil.example. What if evil.example loads an image from site.example? Well, it's very easy. Since the host of the server and the domain of the browser tab does not match, the browser will say, this is a cross-site request. And now the server can decide, do we want to respond to this? Yes, no, maybe I'll just redirect. And since it's like an image load, it's SECFetch mode, no course. So basically with this additional information, you can build some actually pretty simple logic on the server to protect against XSRF, XSSI, some parts of Spectre, some parts of clickjacking, and the code is actually trivial. First block is just for compatibility reason. If you don't have a SECFetch site header on the request, you just say let it pass because that browser does not support this security feature. The 2 important ones are these here, like the 2 below. You basically check if SECFetch site is basically same origin or same site. You basically can customize this, right? You can just allow same origin. And basically, if it's like same origin, like your site made this request to your server, you say, okay, this is fine, I allow this request. If it is cross-origin, because otherwise it would have, if it's not, it would have returned here. If the request comes from a cross-origin context, then, well, you could block right away, but that would have an unpleasant side effect that no one on the web could link to your site anymore. So you would basically isolate yourself from the internet. This is maybe desired for some places. If you like a high security banking app, maybe you just want to have your landing page accessible from the internet, right? So the last section basically just checks, was this a navigation? And if yes, was it a navigation via GET? And in that case, we also allow it, so we can still link to our pages. And that's about it. It's pretty simple. And when rolling it out, you basically would deploy this logic first in monitoring mode. You just log instead of block, right? You would basically look at all the endpoints that have been blocked have like a lot of block entries, and then you look at these, right? Maybe it's a course endpoint. These endpoints are supposed to be called cross-origin, right? So you would maybe opt them out. Or maybe you are like serving static content or like CDN-like stuff. So we might also opt them out. And then in the end, you just enforce this and you're done. This is actually shipped in July in Chrome. And I think Firefox is working on it. The new Edium on Chrome will also get it. So we'll have some broad support pretty soon. There's also a playground. It's not very polished, but it will give you the idea. And there's also some open source implementations of this very simple logic for this SECFetch site handling. The idea is you could build like a very easy middleware for any programming language, right, and immediately protect against a couple of these attacks. Last mechanism is for protecting your windows or like your window references, and it's called cross-origin opener policy. Anyone heard about that? It's even more esoteric. Oh, one, not bad. So I feel I really deliver some new content to you folks here. So that makes me actually very happy. So we'll be the first ones, in St. Pölten who know about this. What is it about? So as I said, evil.example can do window.open on victim.example, and it will maintain the reference to that window. With that reference, it can post message. It can count frames. It can even change the location of this window. It can check if this window has been closed. So the thing is, although these things are like cross-origin, the browser allows a lot of information to flow between these contexts, right? And in some browsers, this link also causes both tabs to end up in the same process, which makes them vulnerable against Spectre-like attacks. So evil.example can attack victim.example. What can you do? Well, you set a response header. You maybe have gotten the theme of my talk a bit here, right? So basically, if victim.example sets cross-origin opener policy, same origin, the browser will say, okay, this page opted out of basically having a reference to it. So what happens, evil.example can still open that window, but it will not have this reference anymore. And that basically means that all the attacks we talked about, like on the 2 slides before, will not work anymore. And browsers that don't have proper process isolation will also be able to put these 2 windows into 2 different browsing contexts, protecting against Spectre. So that's everything about COP. This is actually brand new. The spec is still changing. There is a prototype in Firefox nightly. Chrome is working on it. And yeah, there's also a couple of very interesting research topics in that area, especially with cross-site search and cross-origin data leakage. And, I basically tried to put everything on a single slide. So if you take a photo, I think that would be the one. It was a very high-level talk, and every of these topics basically could, need a bit more in-depth explanation. But I also linked a couple of. Is everyone almost done? Yes. So there's a couple of links here with other slides and talks. I hope I could give you a bit of an overview of this topic. I'm very passionate about this. And I don't know, if you're also passionate about web security, we're also hiring and we also have internships. And I actually did an internship myself at Google and somehow they kept me. So thank you very much for your attention. And I don't know if we have time for questions. I see Bernhard is already walking up and down. Oh, you have a wine, that's nice. So, okay, yes?
Actually, 2 questions. First one, why can't you just use the origin header, which is set anywhere?
The origin header is not there all the time. So origin header is usually there if you do course, but you cannot rely on it. So that's the problem. That is like for some browser-initiated things. Like if you have a new tab or if it's like from a Chrome extension, something that has like no context, so to say. Any other questions? I will still be roaming around. Oh, yes. Okay, no more questions. Thank you very much.